Hi, in this video, we are discussing the third question from the exercise for the chapter Laws of Motion, which is also the fourth chapter for 11th standard physics syllabus. Now, this question is a classic example of the elevator problems or the lift problems, which we discuss in physics occasionally. So, we have a situation where we are witnessing the three instances of a same elevator journey. These keep in mind that these are not three different elevators, but rather these are snapshots of the same journey but at three different time intervals. So initially what is happening कि we have an elevator and हमारा ऑब्जर्वर जो है उस एलिवेटर में चढ़ता है एंड देन वो एक वेइंग स्केल पर खड़ा हो जाता है एंड हमारा ऑब्जर्वर कॉन्स्टेंटली उस वेइंग स्केल को मॉनिटर करता है. सो वो स्टार्टिंग में कुछ एक रीडिंग नोटिस करता है एंड देन हमारा ऑब्जर्वर एज पर द क्वेश्चन नोटिस करता है कि ये जो रीडिंग है वो डिक्रीज होती है for some period of time and then it comes back to its initial reading after that time interval has passed. So now as per the question हमारा challenge है कि इस जो बीच का जो time है, that is in between time, what exactly must have happened so that our reading so that the observer observed a decrease in reading or observer observed a change in reading. So first thing we need to keep in mind that whenever we talk about a weighing machine does not measure mass. In fact, it measures weight. And this weight is dependent upon acceleration due to gravity. So if कुछ ऐसी situation आ जाए जिसके वजह से our G starts to change, so will our reading for our weighing machine. सो हमें पता है कि कुछ ऐसा ही इंस्टेंस हुआ रहेगा कि जिसके वजह से ये जो रीडिंग है वो चेंज हो रही है या डिक्रीज हो रही है. सो वन कंक्लूजन दैट वी कैन मेक इनिशियली इज दैट प्रीवियस फ्रेम्स के मुकाबले जो हमारा बीच का फ्रेम है, जो मिडल फ्रेम है, इट मस्ट एक्सपीरियंस सम सॉर्ट ऑफ एक्सेलरेशन. सो या तो लिफ्ट ऊपर जा रही होगी या नीचे आ रही होगी एंड हमारे जो इनिशियल और फाइनल इंस्टेंसेस है तब लिफ्ट जो है एक अनएक्सेलरेटेड स्टेट में होगी. सो दिस इज द इनिशियल कंक्लूजन विच वी कैन ड्रॉ एंड एज पर द क्वेश्चन as per the question हमारा जो solving है that now gets divided into two case. Our first case is the unaccelerated case and our second case is an example of a motion under accelerated frame. So once we understand this particular situation or scenario, rest of the question is quite easy to deal with. So let us quickly solve this question. सबसे पहले let's see what sort of given data that's been given to us. Now, as per the question, we have been given two readings. Okay, so we have been given initial reading and then we have been given this reduced or changed reading during the middle time frame. So हम दोनों readings हमें पता है कि weighing scale की reading is the normal reaction that it measures. So we have been given normal reaction provided by our weighing scale on the man in the upward direction. So first case का normal reading is 50 kg weight and we need to convert this into Newton because we need SI units for our calculation. So 50 kg weight becomes 500 newtons as 50 into 10. That's the conversion ratio for kg weight to Newton. Now the second value that's been given to us is the normal reaction in the second case, that is the accelerated case. We see a reduced value that is 45 kg weight and again we'll convert this into Newton as well. So now that we have figured out our given data, let's quickly get to our solution part. So under solution, let's first start with the FBD for case 1, which is this, the unaccelerated case. So अगर हम इसमें मैन को एज अ सिस्टम लेकर FBD बनाए, सो वी कैन रिजॉल्व ऑल द फोर्सेस. तो हम देख रहे हैं कि मैन के ऊपर एक force due to Earth's gravitation लगेगा which is its weight in the downward direction and एक जो है normal force लगेगा which is in the upward direction. This is because our man is standing on a weighing machine. तो weighing machine एक force उस पर implement करेगा N1 and this state experiences no acceleration. So इसमें इस frame में there is no acceleration. So from this particular FBD I can come to an equation where I can say that both these forces should cancel out because is particular instance where there is no acceleration. So my weight has to be equal to the normal reaction experienced by our observer. From this equation, we can actually find out the weight of the observer, which is 500 Newton as per the given value. So let this be the equation 1. Also, from this, we know that weight is equal to mass into acceleration due to gravity. So if I have to calculate the mass of the observer, I simply have to divide weight by g, that is 500 by 10. For simplicity, we are using g as 10. So if I have to calculate the mass of the observer, it would be 50 kg. Let this be equation 2nd. So we have found out certain intermediate quantities. Now let us move on to our case 2 to further solve this particular numerical. So in our case 2, हमारा जो FBD है, that is pretty much the same from our previous FBD. The only difference is that now we are dealing with an accelerated frame. So थोड़ी चीजें जो है different होगी. So एक चीज हम make sure कर सकते हैं कि ये acceleration का direction कैसा ले. So now if you are experienced enough, we know that a reduction in rating generally means that we are experiencing an acceleration downward. But let's say for some reason आपने acceleration की direction गलत assume कर ली है, तो भी you don't have to worry, because आपको जो आंसर आएगा वो मैथमेटिकली करेक्ट होकर ही आ जाएगा. So we know कि एक acceleration downward direction में लगना चाहिए. So we are considering acceleration in the downward direction. Now from this particular FBD, I can say that the sum of the resultant forces should be equal to mass into acceleration. This is the Newton's laws of motion. So I know the value of weight, हमने अभी अभी calculate की है. We know the value of n2, that's given to us, and mass की value भी हमने अभी अभी calculate की है. So if we substitute those equations, I can say from equations 1 and 2, we have a lot of known quantities or constants and one unknown quantity. So let us rearrange the equation, all the known quantities on one side, all the unknown on the other. So with this, we get acceleration as minus 50 upon 50, and I can say acceleration ka value comes out to be minus 1 meter per second square. Now what does this represent? This represents कि फर्स्ट केस के मुकाबले सेकेंड केस में हमारा जो एलिवेटर है दैट अंडरगोज an acceleration which is 1 meter per second square in magnitude, and it is directed downwards in terms of direction. So because of this acceleration, हमारा जो weight की जो reading है that is getting changed, because this downward acceleration is now reducing the value of our acceleration due to gravity, and hence उसका effect जो है हमें change in reading के format में दिखता है. So this was the numerical explanation for this particular sum. If you want the PDF of this solution, it's available in the description. So make sure you check that out. I hope this helped you. Thank you.